Okay, I've been seeing people make a few mistakes on domain and range, so I thought I'd go over a few more domain and range type questions with you. So here we are. And when we're doing domain and range, basically what we're trying to do is to say where on the grid the function actually exists. So you can see from this function here that no part of it exists up here and no part of it exists down here. So what we want to do with domain and range is kind of box it in so that you can see where it actually does exist. So I'm going to take the green here and I'm going to box it in left and right. So I'm going to draw my left and right boundaries here. And then I'm going to take the red one and I'm going to box it in up and down. Now you can see that I've drawn the box around it. There's no function, part of that function that is outside the box. So I found the boundaries of the function. So let's see what they are. If we take a look, this green line is at -3. Ooh, that's really big. And this is at +1. So when we write the domain, we'll say D. Domain is all of the x's that lie between those two numbers. So we say x is all the real numbers, so XER, such that, and this is actually epsilon, not E, such that we put our -3 here and a +1, those are our two boundaries, and then we put the x in the middle. Now, x exists in between all of those, and we put in our greater than, less than signs. They always point to the smaller number. So -3 is smaller than 1, so they have to point this direction. Now to figure out whether we need an equal to sign under here, we have to take a look at the points that are at the ends of this function. So I kind of covered this one up. Let's go back and have a look. That's an open circle. It's not filled in. It's got a white center. That means that the function gets to, just doesn't quite get to it. It gets really, really close to it, but doesn't get there. So we can't put an equal to sign on -3. Now, over here, though, it does get there. So we actually need that equal to sign on the 1. Now looking up and down, we want the range of this function. It starts here at -4. That's the smallest value. And the biggest value is 0. So we're going to say y, because we're dealing with the y values this time. Y is any real number such that it lies in between -4 and 0. And it's all the y's in there, so I'm going to put y in between. And again, we're going to point the way to the smaller number. Now let's decide if we need equal to signs. When we take a look down here, that's a filled in circle. So at -4, that's down here at -4, we definitely need an equal to. If we look up here at this, it's an open circle, but take a look across the function. It actually hits the 0 at this point. Erase that a little bit. The function gets up to the 0 line there. So even though it didn't get to 0 here, it does get to 0 here. So since it gets to 0 there, we do need an equal to on both of those. And cap that off. Now here's the mistake that I'm seeing with people doing some of the functions in the journal question. When you go to box this one off, they're paying attention only to the endpoints. So that works really well for my x's. So I can box in my left and right. But if I try to do that with up and down, whoops, that's actually the right way to do it. I'm just trying to do it the wrong way this time. If I do it up and down, I would draw a line here and a line here. Now that doesn't box in the function. What just happened there? Undo. That doesn't box in the function if I go in between those two points. There's all of this stuff up here that didn't get. So if I want to box in that function, I'm going to have to go to this top part here and then this bottom part here. So this is 1, 2, 3, 4, 5, 6, 7, 8. So that's at -8. And this is at 1, 2, 3, 4, 5, 6, 7, 8. So that's +8. And for our green ones, that's at 1, 2, 3. So that's -4. And this is at 1, 2, 3, 4, 5, 6, 7, 8. So that's a +8. So now we just have to do the same thing we did over here. Let's start with the domain. The domain are all of the x's in the real number system that lie in between these two green bars, -4 and 8. So -4 and 8 and we're going to put the x in the middle and point our way to the smaller number. Now, do we need the equal to signs? We have to take a look at those endpoints. Yes, those are filled in circles. It actually hits there. We need to put our equal to on the endpoints. Now, if we do the range, y is any real number such that the two things it lies in between are -8 and +8. So -8 there, +8 there. The y's are all in between those two. And we point the way to the smaller number. And since it does hit here and it does hit up here, yes, we need equal to signs. Now, carrying on, I've got two more functions here that are a little bit different. I can't box these in. This is just a series of points. So we want to do the domain of these points. When I do the domain of these points, I simply just have to see what the x-coordinate of all these points are. So moving left to right, we have a point at 0. There isn't one at 1, but there's one at 2. There's none at 3, but there is at 4. There's none at 5. Oh, actually, there's one at 5 right there. And there's none at 6, but there is one at 7. And you can just do it that way. And the range, if we go down here, we've got a bunch at, that's 1, 2, 3, 4, 5, 6, 7, -7. So we get 2 at -7. We've got 1 at -2. We've got 1 at, that's at 5. And the last one is at 7. And you'll notice that the range, since there was a duplicate down here, the range has more numbers than the domain, and that's perfectly acceptable. Now this last one, we can't box it in, and we can't box it in because it's got an arrowhead that's going forever in that direction. So always look to make sure whether you have an arrow or a dot. If you have a dot, then it stops there. If you have an arrow, then it keeps going in that direction forever. So let's take a look at what we've got here. I'm going to box it in the best that I can, left and right, which is this line. So I have, that's a beginning point because there's nothing before it, and there's everything that comes after. And then we have this line up here. There's nothing above it, so that's like an end point. It doesn't get any bigger than that. And let's figure out what this point here is that's so interesting here. This is -1, 2, 3, 4, 5. So -5, comma 1, 2, 3, 4, 5, 6, 7, 8, comma 8. So now let's build our domain and range from this because there's not going to be any endpoint on it. So our domain, x is any real number such that, well, our x's start at -5. So I'm going to put an x and a -5 there. Now I just have to figure out whether I want a less than or a greater than sign. Is this blue hitting all of the points that have x's that are bigger than -5 or less than -5? Well, when you're looking at left to right, all the small numbers are over here and all the bigger numbers are on this side. So the blue is on the bigger side, so we have to use the greater than sign. And that's an open circle there, so we don't use the equal to sign. So that's done for the domain. And for the range, when we look up and down, y is any real number. So we're going to say y, and the cap point for the y is this 8 value, the y coordinate of that point that was so interesting to us. And we just have to decide whether all our y's are bigger than 8 or less than 8. Well, you know that these are negatives down here, so that all the small numbers are below when we're talking about looking up and down, and all the big numbers are above. So what we have here is all of the numbers that are small. So there's less than 8. And again, this is an open circle, so we leave that open. And we'll just cap that off with a squirrely bracket. And that's it. I hope that gives people a little bit more to go on.